Okay, we'll go over last week's questions before we start in this week's content, because this week's content is very much going to build on Newton's second law and just show through a few situations where it's a little bit more tricky. So I get into the habit of trying to keep things as simple as possible. So question 1 says there's a resultant force. I'm actually doing the harder ones first. Let's start off with the easy ones. First question says a car has a mass. So we've got mass is 2,500 kilograms. We need that in kilograms. Accelerates at a rate of 3 meters per second squared, and we're looking for the resultant force. Write out the equation always, because it gives you at least 1 mark. Put in your values. And multiplying that out will give us 7,500 as a resultant force, so it is newtons. Next one, similar thing. Mass is 10,000 kilograms. We have an acceleration of 4 meters per second squared, and we're trying to find the resultant force. Write out the equation. Write it again, but put in your values. So we have 10,000 times 4, so our resultant force is just 40,000 newtons. Next one's a little bit trickier, but it talks you through it. We have a ball of mass 150 grams. That's a problem, because in our equation for Newton's second law, it needs to be in kilograms. So the first thing we have to do is divide that by 1,000, which tells us that the mass is actually 0.15 kilograms. Only then, once we've got that, can we use our acceleration in conjunction with that to find out the resultant force. So RF equals MA, RF equals mass is 0.15 times 20. So the resultant force will be 3 newtons. Next one, a little bit trickier because it's harking back to some of the previous lessons. It says a car of mass 2,000 kilograms. So that's okay, we've got our mass in kilograms. Accelerates at a constant rate from rest to a velocity of 10 meters per second in 5 seconds. Now we're going to come across an equation that will allow us to work this out, but we have to, at this stage, think back to what acceleration means. And acceleration just means it's how much the speed increases by each second. So if it went from 0 to 10 meters per second in 5 seconds, that means it increased by 10, but it increased by 10 across 5 seconds. So each second it must have increased by 2 meters per second squared. Once we have worked that out, then I'll just go back and explain that a little bit more. Our car started at 0 meters per second. 5 seconds later, it's traveling at 10 meters per second. But what acceleration tells you is kind of how much the speed increases by each second. Okay, so it's going to go 2 meters per second, 4 meters per second, 6 meters per second, 8 meters per second. So each second the speed is increasing by 2. So across the 5 seconds it would increase to 10. So each second it's increasing by 2. So our acceleration is 2 meters per second squared. Once we know that, we can then work out the resultant force, because resultant force is mass times acceleration. Our mass is 2,000 times the acceleration of 2, which is 4,000 newtons.